to the arithmetic mean, and the only way it can be equal is if every number in the sequence is identical. That is, if all these returns were 10, then the mean arithmetic would be 10. The geometric mean would be 10 also. How's that? Well, just imagine if I keep multiplying 1.10 times 1.10 times 1.10 for however many of them there are, and then I take the nth root of them, well, I'm just going back to where I started, right? So, for example, 1.10 times 1.10, then take the square root of it, what do you get? 0.10. Any variability in the series, the geometric will be lower, and that's why they require mutual funds to specify the rates of return, not in terms of the arithmetic mean, but in terms of the geometric mean. Okay, so how are we doing on that? Okay. Kenzie? Good? Okay, now, this starts becoming a little bit more complicated, and I'm going to show you how to do something on your calculator, but so you will have the ability to do it at some time. That's not good. Okay. What this is doing is putting two assets together and seeing how they move relative to one another. So you know what correlation is. That's the tendency for things to move together, specifically to be above or below their respective means. And if you've got two assets and one in a period is above its mean and the other in the same period is below its mean, that's kind of a good thing because it means that they're knocking each other off and you end up with less variability in your portfolio. But for this, what we're going to do is just say, let's calculate, go ahead and clear your calculator, and we're going to go into the data mode, second data, and now we need to clear everything out, so we're going to say second clear work, second data, second clear work, and I'm going to look down there and know there's nothing in there. I'm going to get back to X1. Now here, I have two different sets of returns, two different assets, two different sets of returns. And so in this one, this is just asset C and asset D. And we've gone ahead and calculated, well, here's the mean for asset C, here's the mean for asset D. Now, we could go through and put these numbers in using our data stuff, and let's go ahead and do that. So, I'm going to use X for this column and Y for this column. Okay, so 0.12, enter down, and now we're going to put some in for Y, 0.09. So we're going to go XY, XY, XY. You good with that? So right now, I'm waiting for X2, 0.12, change signs, enter down. 0.04, change signs, enter down. 0.24, enter down. 0.32, enter down. So once you get to, when you get to X06, you're finished. Okay, we good? Okay, we're going to do the same thing as we did before. We're going to hit second, stack. And now let's hit the down key once, and it says n equals 5. Another time it says the mean of x is 10. Another time, s of x, let's go one more, sigma x, because that's what I'm showing here, sigma x. And look where my finger is pointing here, 0.122638, and that's what we have here. And we go down one more, and we've got our mean for y, and one more is the sigma, and that's n-1 version, that's the population version. Go down one more, and it says this is the sigma for the population version. Sorry, the first one was sample, this is population. You go down one more, it says A, and one more, it says B. So what's that all about? Well, here's something for your statistics. We have an X value and we have a Y value, and our X value is that first column. Our X value is this first column, our Y value is this column. So what this is saying, I'm going to go back to the A, is that we have an intercept of 0.0571, and we have a slope, B, of 0.9281. Maybe y'all get that in your calculators? Okay, so what does that mean? You've got a line that looks, it's not quite a one-to-one here, but pretty close. So this is a slope equal to 0.9282. So every line can be expressed as y equals a plus bx. And here we're just saying the a is 0.0571 and the b is 0.9282. And if we were to go further on this, hitting the down key, one more, this gives R. What's R? Correlation. So this is the correlation coefficient. Now, if we wanted to know what R squared was, we could just square that. And I think if we just hit this X squared key here, it says that R squared is 0.8803. Most of that makes sense? Okay, so I am going to post this, and you know, it's actually for the other class, but you can watch it too, because I know you have lots of free time and you get tired of binge watching stuff, so this will be great. Wait a second, that's a good question. What is R squared? R squared is also referred to as the goodness of fit. The goodness of fit. So we're looking for, if a line is a very good representation of the dots. The dots represent X in period 1, Y in period 1. X in period 2, Y in period 2. X in period 3, Y in period 3. Wherever those dots are, how well does the line that we just drew, how well does that line actually represent those dots? If it's a very high number, like close to 1, it means that's a good representation of those dots, and indeed the dots are very close to the line. If it's like 0.2, then it means it's a scatter diagram and it really doesn't tell you much at all. Okay? Rock and roll, have a good weekend.
So we should be able to get 10 or 12 questions done?
Yeah, you probably should go down and present your meeting.
They're not on the thing. There are.
Only a little more time.
I will post this.
I'll see you. Turn in my homework.
We'll do Tuesday if we can't finish it. If it's like that's an hour, we'll just finish it up. I assume that. We'll just put an hour into
But we
Tuesday.
should be able to,
If it's harder or if it's gonna take longer. I looked at it pretty, literally, it's like, I think we can do it.
I think everyone.
Honestly, the person didn't want since I'm,
But I'll take a look.
yeah. So then, meeting tomorrow, to these questions, it says we should be able to get 10 or 12 questions. Based on what we did today.
Thanks for the question.
Yeah.
So satisfied, buddy.
Say that I have yeah, it is. Said that I have $1 million, and let's say 5 years. But I think it's going to be worth $100,000 5 years from now. So I could subtract 100,000 from $1 million and get 900,000. And then instead of deducting 200,000 per year, which would be $1 million divided by 5.
So you do with that one instead?
Yeah, you would take this and divide it by 5, and that would be your depreciation. And then at the end, the book value would be 100,000 because you would have depreciated out 900,000. So that would be like 180,000 per year. And then at the end, it's worth 100. If you sell it for 100, well, there's no tax ramification. So I don't think that's what I said on this, though. I think I thought if you look at the most current version, I think it just says depreciate it all the way out. So depreciate the $1 million all the way down. But at the end, there are 3 different possible depreciation amounts.
Oh, I didn't know there was another one.
Another one?
You said there's a new version of it?
Well, it's like a week ago.
Yeah, I didn't know.
Okay, so you've already been working on it?
Yeah.
Oh, well, you'll like this one.
Okay.
So it's probably made clear. Why don't you look at it, and then if you have a question about it, send me an email on the question.
Okay.
But what it's gonna do is allow you to depreciate this out completely, then which is gonna be easier. However, the 3 different cases have 3 different actual salvage values at the end.
Okay. All right.
And that I think was already in there. So what the change I made actually made it easier.
Okay, thank you.
Okay, see you later.
Tell me the camera's not for me. Is that the camera you borrowed?
Oh, it's a school's camera.
School's camera? A couple of times I've asked them somebody and have tech come in to do it.
Yeah, that's what they did.